Right, in this video, we're going to look at measures of variation, and we have two different kinds that we are going to look at. We have range and standard deviation. So it's a measure that describes the spread of the data. And then, for example, we have range and standard deviation. Range you should already be familiar with. It's the difference of the greatest value and the least value. So if we're looking at these two different scenarios, we have show A and show B. You're looking for the highest and lowest contestant for each. There's 12 contestants, so that's going to help us out later on when we do the standard deviation. So for show A, if we locate the highest, it looks like we have 31, and the lowest is 19. So 12 years spread out between the lowest and the highest. So it shows you the spread of how far apart the data is. And then for the other one, we have this one we would have called an outlier from the first page, a 48-year-old contestant minus also 19 as the youngest age. So this appears to be more spread out, but it might again be the outlier that's kind of throwing off the data a little bit, because beyond that, I mean, the other one, the next oldest is 32, which is more like the first show. So the way we can kind of look at that spread a different way, rather than just doing the highest and lowest, is something called standard deviation. And we're going to do of a population. And we can do of a sample as well. So the standard deviation is a measure of how much a typical value in the data set varies from the mean. I would just underline those two things. We have a symbol for this called sigma, and that's going to be for the population. Now we are actually going to calculate this using a chart, and we're going to do it by hand, but I'm going to give you what the formula would be for this. It's going to be each data piece minus the mean, and then squared, and then we're going to add them together. So it's the sum, just like a mean would be, but we're going to calculate these little pieces that we're going to add together. I just put plus sign in the last one, and it should be a minus. Sorry about that. And then because we're going to be doing a population, we're going to do divided by n. If we're looking at a sample would be n minus 1. We're only going to do the population. And depending on the order of how we do this unit, you may already understand population versus sample, or we might look at population versus sample at a later time. All right, so the way this is going to work and how you're going to do your calculation, rather than filling directly into that formula, we are going to set up a chart. So you have to kind of know this chart, and when you're doing your practice, you're going to set it up the same way. So we're going to list all of your data values in the first column. We're going to subtract off the mean in the second column. Oops. Try to make that a little bit straighter. And then we're going to square our answers here. Now when I do the subtraction, I actually just put positive answers since we're squaring it anyway, and you're not going to be tempted to put negative answers in that right column. So everything in the right column should be positive. Now we're doing show A. And we want to calculate the mean first by doing the sum divided by 12. You could take a minute to do that in your calculator. I'm just going to scroll back real quick. So here's our data for show A. You're going to do 20 plus 19 plus 25 plus 27 and so on. Add those all up, hit enter, and divide by 12. You should get a mean of 25. You don't really have to show work for that. You can use your calculator for it. So then what we're going to do is take all of the data from that chart, and you might have to just flip back and forth to grab it. I'm going to just write it out in the order that I see it. And after you write it all down, since we know that we have 12 pieces, I would just recount and make sure you have 12. A little bit. There we go. And then we're going to subtract 25 from each of these. So the difference between 25 and 20 is 5. I'm just going to put 5 here. So I'm kind of doing the absolute value. Technically it's negative 5, but since we're going to square it and make that 25 anyway, it's really just the difference that we're looking for. And then 4, 6, 3, 0, 2, 2, 4, 5, 5, 4, and 6. And this down the line is something you can do without a graphing calculator, because these numbers we could square without too much difficulty. I think on the practice, you're definitely going to need the graphing calculator because the numbers are a little bit harder. But I know for a fact on the quiz and on the test, I kept the numbers simple. And then to get the sum, so if we just scroll back a little bit, we're trying to add everything up here. So what I just did was I got each of these values, the x1 minus the data value minus the mean, and then square them in that last column. So because I'm in the chart format, it makes it a lot easier to get the sum of this last column. So if you add everything up down this last column, you're going to get a sum of 212. And then you're going to do the square root of 212 divided by 12. And usually I would just recommend doing a little bit of simplifying. So this would be, you could do 212 divided by 12 and you get 53 over 3. Honestly, you could leave it like this. If you have a calculator that can do radicals, then you could type in and get the approximate answer of 4.2. So this is your standard deviation. What does that mean? It means the typical age of a contestant on show A varies about 4.2 years, you want to put units on that, from the mean. Oops, I'm sorry about that. So the key again, typical age varies. And then the 4.2, since that is our standard deviation, the typical age of a contestant on show A varies about 4.2 years from the mean. So you'll have to make some sort of statement about that in some of your standard deviation questions. So the key when you're doing your practice is making this nice chart and following through with the steps. If you have to rewatch this a little bit to get you through that first example when you're doing your practice, definitely do that.